Hello everyone, I am Dr. Parameshwari, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In this video, I hear about the numerical methods and complex variable subject, and in this I will take the Cauchy's theorem and Cauchy integrals formula. Now Cauchy theorem and Cauchy integral formula, so first we have to know about the simply connected region. A region R is said to be simply connected if every simple closed curve in R, it contains only points of R. In other words, simply connected region is one which has no holes. Now example, interior of circles, rectangle, triangle and ellipse. Multiply connected region, and this one is a simply connected region. Multiply connected region, a region which is not simply connected, and this one is called as multiply connected region. And in this two multiply connected region, this one is a doubly connected region and this one is multiply connected region. Now Cauchy's theorem. Here Cauchy's theorem statement here I will give. If f of z is analytic and f dash of z is continuous within and on a simple closed curve C, then contour integral C f of z into dz is equals to 0. This is the Cauchy's theorem. Now extension of Cauchy's theorem for multiply connected region. Multiply connected region means here region having, that is C having C1, C2, C3 in simple closed curves form. If f of z is analytic in a multiply connected region enclosed by C and C1, C2, C3, Cn are n simply connected simple closed curves within C, then contour integral C f of z into dz is contour integral along C1 f of z into dz, contour integral C2 f of z into dz and so on. So contour integral Cn f of z into dz. Now Cauchy integral formula. Now here f of z is analytic within and on a simple closed curve C. That is here z0 is any point within C. Z0 is any point within this closed curve C. Then here contour integral C f of z upon z minus z0 into dz is equals to 2 pi I into f of z0. This is Cauchy's integral formula. And in this Cauchy's integral formula we have two formulas are there. One is if the z minus z0, this singularity having order 1, then we use this formula. And if we integrate with respect to this equation 1 with respect to z0, we get contour integral C, and with respect to z0 meet it is in a form of 1 upon x, and 1 upon x derivation is minus 1 upon x square. That is here we get f of z upon z minus z0 whole square into dz is equals to 2 pi I into f dash of z0. Now in generally contour integral C f of z upon z minus z0 whole power of n into dz is equals to 2 pi I upon n minus 1 factorial f power of n minus 1 into z0, here where n value is 1, 2, so on so. Now singular point. Singular point means here a point at which f of z is not analytic, it is called a singular point or singularity of f of z. Example, the singular points of f of z. Here I taken the f of z value is z power of 4 plus 2 upon z minus 1 whole square into z square plus 1. And here if we calculate the singular points means we equate the denominator value into 0. If we equate the denominator value into 0, that is here we get z is equals to 1 and z is equals to plus or minus I. And this z is equals to 1 having order 2 and z is equals to plus or minus I having order 1. Now here e raised to z, sin z, cos z, z power of n is belongs to positive values of z, are analytic everywhere but it has no singular points. Now here I use the Cauchy's theorem and Cauchy integral formula in some problems. Here I will take the first problem. Evaluate contour integral C 3z plus 5 upon z square plus 2z into dz, where C is the closed curve, modulus of z is equals to 1 by using the Cauchy integral formula. Now if we want to solve this problem, first we have to calculate the singular points. And how we calculate the singular points here? We equate the denominator value into 0. That is, so first here we equate the denominator value into 0, that is z square plus 2z is equals to 0. That z square plus 2z means in this if we take the z common, z plus 2 and it is equals to 0. That is z into z plus 2 is equals to 0 means here if we write separately z is equals to 0 and z is equals to minus 2. And these are the two singularities having the order 1. Order 1 means here power is 1. That is here I will mention order 1. Why? Because if we want to use the Cauchy integral formula, we have two formulas are there. One is order 1 and one is order n. Now this is the first step, we calculated the singular points. Now we have the second step here, we check these singularities are inside the circle or not, and here in circle condition is given, that is here we write the first circle condition, modulus of z is equals to 1, and here we have to check these singularities are inside the circle or not. Modulus of z is equals to 1 means here we know the modulus of z value is x square plus y square is equals to 1, that is in graphically modulus of z means having the circle, and this one is modulus of z is equals to 1. Now we have the first singularity, z is equals to 0. So z is equals to 0 means in a place of z if we replace z is equals to 0, that is 0, that is 0 we know clearly it is less than 1. Less than 1 means it is inside the given circle, that is here I will write inside the circle modulus of z is equals to 1. In graphically z equal to 0 means this is at the origin, z is equals to 0, and this is z is equals to 1, that is z is equals to 0 means it is given the inside the circle. Now we also check z is equals to minus 2, that is here we check z is equals to minus 2 in a given circle. We have the circle condition is already given, modulus of z is equals to 1, that is here I will write modulus of z is equals to 1, and if we replace z is equals to minus 2 in a place of modulus of z, that is modulus of minus 2 is 2, and that 2 is greater than 1. In graphically if we want to show, this one is our z is equals to 1 circle and z is equals to 2. Z is equals to 2 means it is outside of the circle, otherwise z is equals to minus 2 means this is z is equals to minus 2, and it is clearly from the graph z is equals to minus 2 singularity is outside of the circle, and we know Cauchy integral formula is only apply where the singularities are inside the given closed curve, otherwise on the closed curve, that is here z is equals to minus 2 is outside of the given circle. That's why here we will not apply the Cauchy integral formula of the second singularity. We apply only the singularity of z is equals to 0. Now here we are writing f of z is analytic, f of z is analytic everywhere within C, within and on C, within and on C. Now here I will apply the Cauchy integral formula, Cauchy's integral formula, and we know clearly the singularities are having the order 1, that is a Cauchy integral formula we have. The Cauchy integral formula here I will write the statement, that is f of z upon z minus a into dz having the order 1, that is order 1 means this power is 1 into dz is equals to 2 pi I into f of z naught. This is a Cauchy integral formula. Now here our f of z, that is f of z value is a contour integral 3z plus 5 upon z square plus 2z. I will write here contour integral C 3z plus 5 upon z square plus 2z into dz. That is here we write the Cauchy integral, we use the Cauchy integral formula means we have to write f of z upon z minus a, and from the denominator we know clearly z equal to 0 is inside, that is here I will write 3z plus 5, and this is z, if we take the z common, z in bracket of z plus 2, that is here we will write z plus 2. We consider this total value is f of z upon z minus z naught, we have the z naught value is 0, having this order is 1 into dz, and here we know the Cauchy integral formula 2 pi I into f of z naught, that is here we write 2 pi I into f of z. We have the f of z value, this value totally we are considering as f of z, that is 3z plus 5 upon z plus 2 having z value is 0. That is if we replace z value is 0 here, that is 2 pi I in a bracket, replace here z value is 0, 0 plus 5 is here we will get 5, 0 plus 2 is 2. That is if we cancel 2, finally we will get the 5 into pi I, and this is the line integral we are evaluating the using the Cauchy integral formula. Now here we will discuss about the second problem, order n, that is using the Cauchy integral formula we have to evaluate contour integral e raised to 2z upon z plus 1 whole raised to 4. In first problem here I explained about the denominator, that is the singularity values having order 1, and here from the denominator if we calculate the singularity, here having the singularity order is 4. Now first step is here, from the denominator we have to calculate the singularities, that is if we equate the denominator value into 0, that is z plus 1 whole power of 4 is equals to 0, that is z equal to minus 1, and we know clearly this is having order 4. That is here we write order 4. This is the first step, we calculating the singularities. After calculating the singularities, second step is we have to check this singularity is inside the given circle or not. Already here circle condition is given. Here I will mention the circle condition where C is a closed curve, mod Z is equals to 3, and we know mod Z is equals to 3 means this is the equation of a circle. Now in this circle we replace the singularity, and here our singularity value is Z is equals to minus 1, and if we put Z is equals to minus 1, that is if we put Z is equals to minus 1 means modulus of minus 1 and it is equals to 3. Modulus of minus 1 value is 1, that is 1 is less than 3. Less than 3 means it is inside the given circle, inside the given circle. And if we take this singularity in a form of a graphical representation, that is I will take the x-axis and y-axis, modulus of z is equals to 3, that is modulus of z means x square plus y square, and this value is equals to 3, that is this one is modulus of z is equals to 3 circle. And here we know clearly the singularity we have z is equals to minus 1. Z is equals to minus 1 means here we know z value is x plus iy, and that is x value is minus 1 means z is equals to minus 1 is inside the given closed curve mod z is equals to 3. That is this is the graphical meaning of modulus of z is equals to 3. Now we know it is clearly this singularity is inside the given circle. We complete the second step. Now we have the third step. The third step is we use the Cauchy integral formula. That is using the Cauchy integral formula, and we know clearly here f of z is analytic everywhere within and on the closed curve. That is using the Cauchy integral formula we have clearly know the singularity is having the order 4. Order 4 means we have to use the second formula, that is the Cauchy contour integral C f of z upon z minus a whole power, otherwise z minus z naught whole power of n into dz, and it is equals to 2 pi I upon n minus 1 factorial f power of n minus 1 into z naught. That is here I will write our function. In question line integral is given contour integral of e raised to 2z upon z plus 1 whole power of 4. That is here I will write contour integral e raised to 2z upon z plus 1 whole power of 4 into dz. That is we have the singularity z is equals to minus 1. That is here we write 2 pi I upon n minus 1 factorial. That is here we have the n value is power, that is 4. Means here we write 4 minus 1 factorial f power of 4 minus 1 into z naught. We have the z naught value is minus 1. That is if we simplify this one, we get 2 pi I upon 4 minus 1 factorial, we have 3 factorial f power of 3 into minus 1. That is here f power of 3 into minus 1 means here we have the f of z value is already we have, that is f of z value is, we compare the f of z value into our integration e raised to 2z, that is f of z is equals to e raised to 2z, and we have to calculate the f power of 3 times. That is if we calculate the first derivative of z, that is 2 into e raised to 2z, second derivative 4 into, that is the second time derivation 4 into e raised to 2z, and the lastly third time derivation of z is equals to 8 into e raised to 2z. That is here I will write the 8 into e raised to 2z derivative 2 pi I, and the 3 factor means 3 into 2, that is 6, and f power of 3 minus 1 we have the third time derivation is 8 into e raised to 2z, and we have the z value is minus 1. That is if we replace z value is equals to minus 1. That is if we simplify this one, 2 pi I upon 6, 8 e power of 2, and we replace z is equals to minus 1. That is, if we cancel this one, 2 I in this 3, 8 by 3 pi I and e power of minus 2. And this problem is having the order 4. And in these two problems I explained the Cauchy integral formula 2 condition, one is order 1 and one is order n. Thank you.